Good afternoon. Okay. So we've got the show on the road. Yeah. Good afternoon and welcome to the 23rd annual exhibit of Hydrogen and Fuel Cell Technologies. This is an event. We've been doing this for several years. It started as a small idea, electrolysis, that branch of application or science where we split the water molecule. We get hydrogen and oxygen. The hydrogen particularly of interest here. We thought it would be nice to get various manufacturers of electrolyzers up on the stage and discuss the differences between their technologies, the similarities, the applications, what size factors play a role, what efficiencies, cost factors, the whole cost of a system, durability, and so on. This is vital because, of course, renewable energy does not appear the moment you need it. So for things like storage, it's important. It's also an industrial gas. So this gets complicated. As I said, it was a small idea, and quickly, within a few years, we had 11 manufacturers of large electrolysis systems. And if you can imagine the stage here with 11 people, tendence rising, it was a bit too much. We've had to divide it. Now, this says something about the electrolysis industry. It is booming. It is very important. It provides hope for storage of renewable energies and its utilization later. It also has other applications, of course, remote applications. So today we'll be dealing with one side of this equation, although not exclusively, smaller and medium-sized applications, remote applications, but also a large manufacturer will be joining us on the stage. Together, 5 people. First up will be Bertrand Amelot, who's Executive Vice President of Sales and Marketing at McPhy Energy. Second on the list is Carsten Krause, Managing Director of Areva. Then we'll be talking to Henrik Steen Pedersen, who's Executive Vice President of Sales and Partner Management at GreenHydrogen. Next up on the list is Nils Aldag, Sunfire. Then Jakob Krogsgaard, Senior Vice President of Nel Hydrogen. And last but not least, Vaitea Cowan, who is marketing of Enapter. Now, 5 presentations, no, it's not that long. They each get 5 minutes. It's an elevator pitch. You imagine the elevator doors opening, someone talking as quickly as possible, and at the end of those 5 minutes, the door shuts, that is, the microphone gets turned off, and the next person is up on the stage. Why this format is interesting is because we have the leading people in this field, and at the end, we will engage in a discussion, perhaps a debate. No fist fighting, of course, but it is interesting. There are different takes on whether certain technologies provide certain advantages or not. This is, I think, the big attraction. You actually have the specialists in this field communicating with us and with each other. You'll have the opportunity to ask your questions, and I certainly know I have some. So without further ado, we'll begin with Bertrand Amelot, who's Executive Vice President of Sales and Marketing at McPhy. Please welcome with me Bertrand Amelot.
Okay, thanks. So 5 minutes, I put my chrono. Oops. Okay, good afternoon, and thank you again, Brian, for the introduction. It's a pleasure to be here, and why I will give a few numbers, only some numbers at the introduction, and then no number to give you the state of the art of what we consider water pressurized electrolysis. The good numbers we are very happy to share with you. First is McPhy has 10 years, so we were born in 2008, and now we are on track and even more for the coming years. So we have 10 years. Another 10 is we reached 10 million euro turnover last year, and more to come this year. More to come with new technology, and it's another 10. I'm sorry, it's the magic number for us. It's a technology that I will present very quickly, but then you will have more details tomorrow during the technical forum that we call Innovation on Augmented Electrolysis. So it's 10,000 amps for the wide, and a lot of you are technical people, 10,000 amps per square meter for alkaline electrolysis. So it means we reach an energy efficiency and current density close to the PEM technology. And another number for us important, we provide, and you will be invited to visit our booth to see that, a new platform which is 20 to 100 megawatts. I could not bring it here. I brought it to the booth. So the 20 megawatt platform is a 3D hologram, but it's real product where we are pushing different projects with the team and with the partners and customers. And so it's a pleasure to be here this year. It's also a pleasure because we think we help, we give our contribution. There is an energy revolution and we bring it to a way to do a clean factory revolution. What do we mean about that? We mean that there are more and more requests to a switch from technical development to large industrial scales, which is true for, of course, for industry who requires traditional hydrogen, but 99% of hydrogen today is coming from SMR, and more will come from electrolysis, and we are speaking about big units. It's true that there is a change of scale for energy with more and more power to gas or e-fuel projects asking for bigger and bigger hydrogen volumes. And it's true for mobility, as far as we were all very focused, and it's still ongoing with vehicles for cars, but there are more demand for trains, ships, and so more and more requests for projects which are 400 or 4,000 kilos of hydrogen. So the trend of the market is bigger volumes and still more efficiency. And this, the answer that we propose on McPhy side, is what we call augmented technology. So what does it mean, augmented? It's a combination of improving the technology at a very small scale, nanotechnology like electrodes or compression unit, to very large scales from engineering and project. So today, we provide to the market technology which are scalable, where we work at the core technology at electrode level, and then we provide modules for electrolyzer which are 4, 20 or 100 megawatts. I will show you the design of these units. Again, I won't give into detail because elevator speech is short, but I will give an introduction of this new technology tomorrow with a partner named AXO, which is a chemical, well-known, large leading company for chemical industry, and where we partner with an electrodes company called Denora, and we will present that tomorrow. The second, of course, is to combine large platform of electrolyzer with large refilling station unit for mobility. So as an introduction, and you are welcome to visit our booth and ask our technical team what is inside this 20 to 100 megawatt platform. To make it short, 30 bar, that's pressurized technology, so it's easy to switch from SMR to water electrolysis. Second is high efficiency. The consumption and the kilowatt hour is one of the best of the market. And the third, it's a flexible load service unit. So we bring, also we can contribute to primary or secondary service. The second kind of technology that we bring is large station with semi-centralized electrolysis for transport, 400 kilo and more, because for bus, for trains, again, units are coming and numbers are getting bigger and bigger. So I reached my 5 minutes, and to deliver that, to deliver bigger units, of course, we need an industrial plan. So we organize and we spent 1 year with the team with McPhy. We have the capacity from next year to deliver, so 2019, 100 megawatt per year with own assets in Italy. Our plant now is designed to do that. And we can go to 300 megawatts in 2021 to serve the market. This plant also in Italy can do 100 stations per year. So we have industrial capacity, we have the right technology, and of course, technology without people and skills is nothing. So we are training and growing the team for supervision and installation, and we keep a track on R&D with a few partners. So the whole together, that's why we call augmented technology, augmented the capacity, augmented the efficiency, and augmented the capacity of production to serve the market. Thank you for your attention. Welcome to visit us in our booth. And more details to come from the new electrolyzer during the technical forum tomorrow with AXO, with introduction also on Denora technology. Thank you very much.
Thank you, Bertrand. Can you hand that to the next person who's on? So we have to keep things moving here. Next up on the stage is Carsten Krause, who's Managing Director at Areva H2Gen. Pleasure to see you back again like last year. Yeah, please welcome with me Carsten Krause.
Hello, everybody. So again, yeah, like in 2016 or 17, I would like to present our company, Areva H2Gen. Our shareholders are Areva. Smart Energy is a family-owned company, and ADEM, it's a French state with venture capital. These are our shareholders going forward. Our company was founded in 2014, so a very young company, but we have both companies. It was a merge from two companies, from Areva and CETH2. So, and both companies develop PEM technology for more than 12 years, so we have more than 30 years experience. We are based in Paris with a headquarter and the production, and we have an office in Germany for business development and sales. And we are worldwide, a network of partners and subsidiaries for delivering the electrolyzer. As you can see, this is a view to our production site. So we have, we can produce 25 to 30 units a year, and we have a grid connection of 2.5 megawatts. This means we can test our electrolyzer, our container, up to 1 megawatt solutions. And it's based in Les Ulis. It's in Greater Paris, in the south of Paris. Our product, so we have a product line, a standard product line beginning with 5 norm cubic meters up to 200. So 1 megawatt in one container, like a plug and play installation. Yeah, flexible use, cost efficient, and like PEM technology, it is high dynamic. So I will come back to this later to see what's going with our project. And the product line, so we have one container up to 1 megawatt, and if you have the solution for the customer for 2, 4, or even 10 megawatt, then it's a solution built up with the customer, even if it's in a building or if it's with a container solution. As you can see, this is a new product. It's an E-Light 5 for industry. We have a very high demand of the industry for a smaller solution. This is a special new design for the E-Light 5, the smallest one, and especially for the industry. Now, to the end of my presentation, I will tell you a few projects or where we are in, and which is interesting maybe also for the discussion. So we see power to gas economics. Power to gas, we have a lot of projects, especially in Germany, but also in other countries in Europe, even if it's Belgium. So we see last year there was a study of Tractarbel and Inicio. So for the early market, and this is a step we have to go. We are in the early market now for the electrolyzer. So we see there's a market for grid balancing in the primary market. So we are in projects, and we're going for a 1 megawatt system going up to 2 megawatt, but this is a real 1 megawatt. So only with a affordable cost effect of 25% more. But then we have an added value. So you have a production from 1 megawatt. So you produce 400 kilograms every day, but you are also part of the grid balancing, and you can add extra revenues. And this is very important to get a business case for the electrolyzer in this early market. As you can see, this is a picture out of this study where you see the early market. So you have minimum is 1 megawatt. And it's not possible to explain all the market in these minutes. But there's a market now, especially in Germany or in other European cities. And we have a lot of projects where we want to go forward to have this very flexible system from 1 megawatt with 100% overload to 2 megawatt to be part of this primary regulation market to get added revenues. So if you want to know more, we have the discussion now, later, and yeah, you can come to visit us on the booth on C53. I would like to see you. Thank you very much.
Thank you. Up next on the stage, we'll be talking to Henrik Steen Pedersen, who's Executive Vice President, Sales and Partner Management at GreenHydrogen. Welcome.
Thank you very much. Yes. Just 1 second. Can we? All right. GreenHydrogen is we're a Danish company, so we've been around for a while. Since 2007, it was established in Denmark. It's a privately owned company, and we have been working on pressurized alkaline systems from day one. Last year here at Hanover, we launched our latest product, which is the Hyprovite A series, which is alkaline pressurized systems. And we're working on project for more than 100 megawatt. We have several orders already that we have in the pipeline. Most of them are, let's say, for together with renewable energy. So our solutions has been designed from the beginning to work with renewable energy. So we are happy to see that most of the projects that we already deliver will be connected either to wind turbines or to solar panel farms right from the beginning. So this has been our aim from the start, and we are happy to see that it actually works. We also have a small series which is a PEM stack solution. So we have sold 20 of those, but those are very, let's say, small systems. So it's for, let's say, different applications. But I'll show you just a little bit more about the products later on. If we take a look at the ownership, we are owned by a utility company, the Danish state through the incubator, and a local gas company. So it's a diversified ownership that is helping us to increase the business as we go on, and where they have, of course, an interest in the complete solution. If we look at the Hyprovite A series, it's a small modular system. So it's only about 2 square meters, and in 2 square meters we can produce about 200 kilos of clean, dry hydrogen on a daily basis. It's pressurized, as we said, so a 35 bar directly is coming out, and it can do from 20 to 90 normal cubic meters per hour. We have different efficiency, which we focus quite a lot on. Even if we have at high load, we are at 85% efficiency. But most of the operations will probably be on lower loads. And even at 50% load, it's 90%, or 25% load, it's even higher, the efficiency. So it's extremely high efficiency we have, which is important when we talk about renewable energy, because the idea is to harvest as much as energy possible and then to convert it into the hydrogen. It's a fully, let's say, automated system. So we have a Hy-Pro manager, our software to manage the systems. So everything is automated, and there's no need for human intervention in the operation of it. This one, the small PEM system that we had is just 1 normal cubic meter, but it's interesting for many, still for private houses, for universities, for schools, where they see the market is also increasing. For small off-grid solutions, it's an interesting solution. So we like to have it in the house, so we have both the PEM and the alkaline in the house. It's clear from our point of view that the alkaline has a much longer durability. We have a plus 10 years life expectation, where the PEM is more like 25,000 hours before the stack has to be refurbished. So it's not comparable, but it's different applications. So that's why it's important to have different solutions for different applications. The systems are modular, so we can put them together, and we can put them together in clusters. So if we want to make 1 megawatt, we can do that. If we want to do 5, we can put it in a cluster, and we can add, and then we have the software to manage it. But all the units are complete systems, so they all have their own dryer, the deoxer. So that also gives a redundancy in the system once you start building the clusters. And our philosophy is quite a lot to build as you grow. We don't want to start too big. We want to start with where's actually the need today, and then we will grow with you, add one more unit or one more unit when it's needed. When we look at some of the production prices that we have calculated based on our solutions, we see that the electricity accounts for almost 2/3 of the price of the produced hydrogen. So that's clearly we have focused a lot on renewable energies, working a lot with companies doing projects, for instance, for wind or solar. So we can directly connect to them in order to actually help them also to have a higher price for the electricity. So they want to upgrade the electricity and not just sell the electricity, but actually sell green hydrogen instead. And we are supporting them in doing this with our solutions, which is designed from that. We work on mainly 4 different areas, which is the automotive, on-site industry, the power to gas, and then the power to power. We see that the refueling station is booming right now, so we are working with our partners to address this market. The industry has been there for a while, and it's still getting more and more interest to have real green hydrogen in some solutions, because more and more clients are getting interested in having a more green footprint. So if you want to be green, you have to use also green hydrogen in your production. The power to power, we see increasingly demands to go off-grid for smaller communities, and we are happy to see that some of the projects that we're delivering right now is for power to power in small communities, and we see a very growing demand for this globally. Completely the big solutions we don't have the demand, others might have, but we are in our market size, which is, let's say, the small medium market. We are not in the big sizes. We see that we don't have the demand yet, but due to the technology also for fuel cells to do a megawatt and the cost, so it's something that is not ready yet. Power to gas, we work on several projects, and it's interesting, especially for wind turbines or renewable, where you have energy that you cannot get any money for due to the low feed-in tariff in the grid. So it's interesting for them to have a dual production. So either you can produce and sell green hydrogen, or you can sell electricity, whatever makes most sense. We work with partners. We're a small company, so what we do is we find partners and help them grow in the local markets. So we support them with our technology, and we tie together in making partnerships. So that's also what we're looking for, is not selling directly to the end users. We want to work with partners that can integrate our solutions in their solutions to make solutions. If it's hydrogen refueling stations or power-to-power solutions, it's all about integrating into a partner that adds value to the market and is close to the end users. We already work with, let's say, a bunch of companies around in, let's say, from Canada, in Spain, or India, or in Sweden, or in different places, and we're happy to welcome even more partners around us. So we will deliver the core components, and then the suppliers will deliver the rest. I think we'll just stop here. I've got some more slides, but all the slides are available on the network afterwards, so people can study more.
Thank you very much. And of course, we'll be back for the discussion, so direct questions will be coming later. I should make a short pause so they have time to shift the presentations. Up next on stage, we'll be talking to Nils Aldag, who's CCO at Sunfire. There he is. Hello, Nils. Good to see you.
Hi, everyone. It's a pleasure to be back here. I was here 1 year ago. I was talking about commercializing solid oxide cell technology, and today I'm here to show to you where we have gotten in the past 12 months. Like I said, Sunfire is a developer and producer of solid oxide fuel cells and electrolyzers. We're about 100 people located in Germany, and we are taking solid oxide cells to a commercial level, bringing it to an everyday reality. Very quickly, Sunfire offers a multitude of applications and has built hundreds of systems on the left side of the picture for electrolysis applications, producing hydrogen, for example, for the steel industry, for the chemical industry, for petrochemical applications. We have an electrolysis system that produces syngas for the production of power to liquids and power to gas. And we have sold hundreds of fuel cell systems for remote locations, households, and commercial applications. So this is the world of Sunfire. Last year I was standing here and I was promising that we will become competitive with legacy technologies such as PEM and alkaline. And I promised that we would scale up the technology to the megawatt scale. So let's look at what we have done in the past 12 months. Sunfire has basically developed two products, the so-called Sunfire High-Link HL40, which has a proven efficiency of 3.7 kilowatt hours per norm cubic meter of hydrogen, which is by far the highest measured efficiency in the whole industry. And this is electrical input AC to a hydrogen output. We have installed our systems in multiple applications globally. As you can see on the right side of the chart, at the fueling station in southern Germany and at the steel plant of Salzgitter in the northern part of Germany. We have proven reliability of systems installed in commercial locations of over thousands of hours and operated those systems reversibly in idle mode, flexibly going up and down at high pace. And in 2017, we have also developed our commercial Sunfire Synlink product, which, as I said, will be used for power to gas and power to liquid applications. And the first commercial project is set to start in 2021 in Norway. So, promises of 2017 becoming a reality in 2018. The scale-up has happened successfully. This is the Sunfire High-Link 200, which is a 1 megawatt connected load, 750 kilowatt nominal power system that produces about 200 norm cubic meters of hydrogen. Again, 3.7 kilowatt hours per norm cubic meter is the efficiency of the system. And our system is capable of operating between 0 and 125%, so super flexibly. So get ready, because Sunfire we have reached the megawatt class. We have the world's most efficient electrolyzer. We have proven reliable operation of a technology that many people believe is still in the lab, which is actually becoming commercial. We are promoting green hydrogen as well as syngas and green hydrocarbons. And Sunfire is turning SOEC into an everyday reality. Come and visit us at booth C47 in this hall. Thank you very much.
Thank you. Two microphones. Oh, yeah, thank you. I'll put this on stage. So, up next on the stage is Jakob Krogsgaard. He's Senior Vice President at Nel Hydrogen. Every year a different face. Please welcome with me Jakob Krogsgaard.
Hello all, and thank you for having me. So I'm going to talk about Nel Hydrogen. So we are, as we say, the #1 by nature, meaning that we have what we believe are the leading technologies within centralized electrolyzers, on-site electrolyzers, and hydrogen refueling stations. We do our refueling stations in Denmark. We do our PEM electrolyzers in Connecticut, the proton PEM electrolyzers. And what I'll be talking about today are the centralized electrolyzers coming out of Norway. When talking about mega and gigawatts, we started our electrolyzer activities back in 1927, and we have already produced 1.2 gigawatts of electrolyzers. So we know how to do it, and luckily, looking at efficiencies, I can say that we are still the most efficient, even beating what is just presented. So what really concerns us within Nel are to put all of these solutions together. So we have our centralized electrolyzers on the left-hand side. It stacks at 2.2 megawatts. giving 485 normal cubic meters of hydrogen, or just about 1 ton. We can combine them in many different solutions. We also use them for industrial purposes, for various power to gas. We also do it with vehicles, as you can see here on the right-hand side. So what is equally important for us is not just to provide the hardware, but also to make sure that the services needed in order to make this a good, long-lasting relationship with our customers, that remains. And we can combine all of that in our solutions. So looking beyond, an electrolyzer is not just making hydrogen. It's also making oxygen. It's also making heat. And when trying to look at sustainable business cases, you quickly realize that if you can utilize the values of these multiple revenue streams, it becomes a better business case and eventually better IRR for the investors. So the electrolyzers, we are all in favor of connecting them to renewables, but it doesn't have to be directly. Because if you connect them directly, you typically have issues in the periods where you don't have wind and don't have solar, and customers invest in the electrolyzers with the purpose of actually using the hydrogen. So we, for the large-scale electrolyzers, we strongly recommend to make them grid connected, and then operate them as you have the renewable inputs coming from the grid. That allows the possibility to also provide balancing power for the electrical grid. That is needed in many of these areas where we have the renewables being a bigger and bigger factor. With storage on site, you can also operate the electrolyzers independent of your consumption. And we're putting those solutions together with customers right now. If we look at electrolyzers and trying to use them for large-scale mobility, you can again see on the left-hand side we have an 8-stack electrolyzer, which gives us 8 ton a day capacity. Connecting that with storage, high-pressure distribution, and then bring that to a typical bus site like this, it's possible for you to make the hydrogen extremely cheap, competitive, and the installation and the bus depot will be just 70 square meters, which is critical, especially in the cities where you have no space at bus depots. In order to make hydrogen hit what we call fossil parity, it's very important to look at the complete energy supply chain. Eventually, it all comes down to the price of the electricity. So it can either be connected directly to renewables, as you see here, or taken out of the grid. If you have the 40 euro per megawatt hour taking electricity out of the grid, you can do your electrolyzers, and after the electrolyzer, you're in the ballpark of 2.5 euros, which is at fossil parity with hydrogen produced out of SMR. We can see that's happening in the markets where this electricity is available in the Northern Europe. So basically, it's from here and then going upwards. This is a possible business case. If you want to use it directly for refinery, for ammonia, for whatever production, that's possible. You can also distribute it, dispense it, and if you do it at sufficient scale, you can get down to the 5 euro per kilogram, which is the fossil parity requirement in order to hit buses and trucks. So what we're also working heavily on are to make bus business happen. And what we can see here are basically the bigger the fleets you have of buses, the more consumption and the better hydrogen price you can get. We see this as the first market that will really take off here in Europe, creating a need for sufficient hydrogen usage. And last but not least, we are extremely happy that we are walking the talk. We have a exclusive cooperation with Nikola. They are a US manufacturer of large-scale hydrogen Class 8 trucks. We are doing first demonstration stations for them now. They are tiny, just 1,000 kilograms a day. The commercial stations will be between 8 and 32 tons a day. And that's basically based out of the standard bricks that you can put together coming from our Nel group. So we are ready to grow. We have done demonstration. We have done industry for all too long. Now we are ready to kick back on SMR. Thank you.
So thank you very much. We're approaching the end. Last but not least, Vaitea Cowan, who's doing marketing at Enapter. Please welcome with me Vaitea Cowan.
Enapter makes the most cost-effective electrolyzers for hydrogen production of up to 10 cubic meters an hour. We design and manufacture an ion exchange membrane, and we install, monitor, and support hydrogen storage systems globally. Our systems support the infrastructure in remote areas. They're deployed in energy-independent homes, or they're used for industrial on-site generation of hydrogen gas. Our Enapter electrolyzer is completely scalable, and today, it is the most cost-effective and high-performance solution for small to medium-sized systems. Our electrolyzer is the ideal solution for high-purity on-site production of hydrogen for up to 10 cubic meters an hour at only a power consumption of 48 kilowatt. Each individual module produces 0.5 cubic meters or 500 liters an hour. Our stacks are small, scalable, flexible, and modular. If we take a look at what's inside, we're using something unique. To make it simple, our anion exchange membrane transports anions only. It is separating the pure hydrogen gas from the slightly alkaline water and oxygen on the other side. But the best part, no noble metals are required to achieve good lifetime and high performance. The Enapter team combines expertise from both electrochemistry and IT. This unique skill set allows us to develop products for the future of energy. Our electrolyzers are the perfect addition to any hybrid energy system. They give power to otherwise wasted energy, preserving them for the future, and they are easy to control. Because understanding the system and the environment it operates in is critically important, we developed an energy monitoring system. Our comprehensive dashboard provides a full view on understanding the hydrogen production. It has remote monitoring and control capabilities made of a network of sensors and clever microprocessors. All communication is highly secured, and we support Industry 4.0 and IoT communication standards like OPC UA and others. Our mobile application is also friendly for end users to understand their system. If you're curious to know more, come by our booth at D57. But for now, I'd like you to come with me around the world to see some of our electrolyzer success stories. In Malaysia, Digi is the third largest mobile operator. This remote base station relies on hydrogen instead of diesel. It has one EL1000 that provides on-site production of hydrogen, and the 5 kilowatt fuel cell provides uninterrupted service made by renewables if the local grid fails. In Chiang Mai, the Pisuya House project is the world's first solar hydrogen multi-house residential project. It has 2 Enapter EL1000 producing hydrogen from excess solar energy. Its storage capacity is 7.5 kilogram, which is equivalent to 130 kilowatt hours from the fuel cells. This project is completely off-grid and provides energy independence to the family. In France, Le Refuge du Col du Palais has a seasonal hydrogen energy storage. It has one EL500 that allows it to be operational year-round with the 2.5 kilowatt fuel cell. Such a project was made with partners, and we can't conquer the world on our own. Academia, research institutions, system integrators, this is your chance to join us on an exciting ride. We are a fast-growing international startup with a team of 22 today and locations in Germany, Italy, and Thailand, and strong partners worldwide. Together, we will change the way we understand energy. We will revolutionize the way we produce, store, and use energy. And as Gandhi said, the future depends on what we do today. Thank you.
So, yeah, you can stay where you are. We can invite all our guests to come back up onto the stage for our now legendary annual conversation about the technologies. This new division, and I mentioned at the beginning, dividing this into two groups presents logistical problems because we wanted separate issues for each day. But you can see when people talk about things that are scalable, and many companies go from small to large or medium to large or service small things, it becomes less feasible to divide things up. I found it interesting, though, that we had a lot of bests or mosts in this presentation. This is the pride of the industry and the cutting-edge companies that are involved in this. But I have to break this down to a few issues, I think. When we talk about the expansion of the business model here, and just to give you an example, the amount of square meters that the electrolysis industry is occupying at this fair has grown dramatically. That's an investment. It also means that they are commercially viable, that this is not R&D. This is a business prospect, and there's many ways of saying it is a business model. So let's break this down to a few direct questions here, and I hope you'll engage with each other and not wait for me. We might even be able to get another microphone up on the stage. I'll certainly hand mine over. Beginning with Bertrand. And the question of bigger volumes. Where is he? Now, a critical comment on this: you can't claim the best and then run. So he better return to defend his position here. I'll have to move on then. Carsten Krause. We used to talk for a long time, we've been here for 25 years, I've been here for 15 years, about early markets. And I'm always hesitant to bank on that. But in essence, the industrial gas hydrogen has been around forever, and now we're talking about emerging necessities based on renewable energy. When you say emerging markets, you mentioned grid stabilization. Can you generalize in what exactly these emerging markets are? Of course, the industrial market has always been there, but what is growing? What explains the growth in this industry?
Yes, so the market is growing, especially for the demand of electrolyzer for the industry and mobility on one hand, and so we have to, the price is going down, and from time to time we have the problems with the price of electricity. So there are a lot of circumstances to reach a business case. So, and especially on one hand, if you have, it depends also on the customer. If you sell the hydrogen to the industry, you get much less dollars or euros for the hydrogen than if you sell it for the mobility, for the buses. So our concept, for example, if you have a 1 megawatt electrolyzer producing hydrogen like 400 kilograms a day, permanent, 100% or 80% for mobility, and then you go in addition to grid balancing, so to get an additional revenue. So to have an additional revenue, for example, in Germany, it could be with 1 megawatt between 80 and 100,000 a year. So you have then added this revenue to the sale of the hydrogen. So, and if you have a total business case, it's very, it depends from city to city or from region to region. But we have project where it is a real good business case to, to bring in the electrolyzer in the business, in the mobility or in industry.
I found it interesting, Henrik, you mentioned not only automated units with no need for human intervention, but also designing specifically for renewable energies. So what gets more complicated when you design specifically for renewable energies?
Well, you can say basically what you need is the fast response. You need to be able to work together with the energy supply, which is fluctuating. So that's just something that we've done from the beginning, and we had it in the software from the beginning to control the system. And of course, the trick has been in order to do it on the alkaline system, which is not obvious. But since we have designed it from the beginning, it was part of the specifications. It's been a basic part in the system from the beginning. But of course, it's fluctuating energies are hard to predict. So the more that you can work together also with the system integrators that we do to help stabilize the system, the better it is. And also to sometimes reuse the hydrogen that we actually produce to put it back into electricity to feed into our own system in order to make sure that we always have the required power for, let's say, minimum operations.
Okay. Did we hear the word reversible? Did anyone mention that? The same unit going in one direction and the other. Now, here's two debates. Why this is interesting, of course, is everyone's dream would be to have a unit with a local source of renewable energy to produce hydrogen, and from that same unit, put the hydrogen back through that unit and have electrical energy coming out. Now, a lot of engineers would say the efficiency would decline. You optimize a unit for one way, it won't be optimized the other way. So I believe, Nils, you are the reversible man today.
Yep.
It's an engineer's dream. Is it possible?
Absolutely. We have done it at steel plant Salzgitter. So the electrolyzer that we have heard of today from the CEO of Salzgitter was not only operated to produce hydrogen, but also operated to produce power from natural gas in that case. But for me, the reversibility is actually just one aspect of those technologies. It's possible, yes. The question is, do markets pay enough for it so that you implement this feature in your system? Another feature which is extremely important, which we have been talking about, is the efficiency of those systems. And it's, of course, more important that you have a very efficient system when you're located in a market like Germany, where electricity prices are higher. If you're located in a market like Norway, where you pay 20 euro per megawatt hour, efficiency is probably not the critical issue. Then you have CapEx, you have probably flexibility, although I also have a bit of troubles to see the business cases for the flexibility. But I think there's a full range of things that you have to be good at. Reversibility is one that we actually managed to prove, and efficiency is the second one, which we believe is extremely important for, say, Central European markets, and that's why it's the second one we're focusing on.
Vaitea, you do off-grid, very, very attractive locations, providing energy and also combining that with renewable sources. Do you also get involved in the production of renewable energy, or are you doing the electrolysis and recovering the hydrogen and turning it back into electrical energy? Do you provide the whole system, or do you work on the electrolysis?
So we do focus on the electrolysis, specifically since the anion exchange membrane is our core competency. That being said, renewables are powering the anion exchange membrane, and the electrolyzer is fully running on renewables. So we work with partners to use the renewables to power the electrolyzer, and we actually encourage it, honestly, just so that it's a really cradle-to-cradle energy storage solution that is recyclable and not just half-half.
Okay. When we look at the general market, and we have to get onto this conversation, I have to ask a few provocative questions as well, but when we have someone from Nel on the stage with this historical background, I kind of wonder, there's a new Japanese member on the floor here. Your firm is almost exactly the same age as our new Japanese member, and he does alkali electrolysis. The historical experiment says a lot, though, because you've been converting electrical energy into hydrogen for like almost a century now. So you do large scale, you do small scale. Still, a member of your company last year reminded us, and this is something someone said on the stage today, only 1% of the hydrogen that is produced now is produced through electrolysis. That is, the business model for hydrogen on the stage now, electrolysis, is currently 1% of the hydrogen budget. It's got to be the growth that keeps you coming back. Where's it coming from?
If you notice my very last sentence, we shouldn't beat each other, we should beat SMR. SMR is hydrogen produced out of steam, methane reforming, natural gas.
Yeah.
So we should beat the 99% that is not green hydrogen. And that is exactly why we are continuing to talk about fossil parity. Mm-hmm. So basically hydrogen produced, when we get to that crossing point, where hydrogen produced out of electricity from renewable sources becomes cheaper than hydrogen produced out of natural gas, we will all be goddamn busy. And that's the point we need to hit, regardless of what specific technology it is here. We see that in so some of the areas down Middle East, you got very, very cheap solar plants. So you got PPAs of less than 20 euro per megawatt hour, which when you then scale up the electrolysers, so we have communicated publicly that at large scale electrolysers we're below 500 euro per kilowatt. So it's possible, and when you then combine those two, very cheap PPA and electrolyser price, you are at hydrogen below 2 euro per kilogram, and that is better than natural gas. So doing that will make it possible for us as an industry to grow rapidly, and then we can use the hydrogen for a bunch of purposes, including clean steel in Salzgitter or elsewhere.
One very quick comment, because I completely agree with Jacob. The effort has to come from the entire industry, because it's right, fighting each other is not the point. We have we have to make certain changes, for example, in the political environment, in the mindset of people, and not only look towards the deserts of the region, but also to our own markets where great potential actually lies. And I think organizations like Hydrogen Europe, for example, do a fantastic job at combining the efforts of all of us to push the industry as a whole. So I completely agree with what has been said.
And one complementary vision. I used to work also on a former life on the dark side of renewable, on the CO2. I used to work for cement plant and glass plant. And I would say that the easiest energy efficiency and CO2 reduction has been done now, to work on ovens, to work on the process. And now the challenge by 2030 is to go to reduce CO2 emission in the industry by 50%. And when you discuss with all the process owners, from steel, from glass, from chemical, from whoever, they said they need to change the process, and to change the process to reach the 50% reduction, they need green hydrogen as a feedstock. So we are just at the beginning of the key challenge, and the good news is that we have the solution with our large electrolyzer for industry to help this industry decarbonize their process. And the second thing is that they see this decarbonization as electrifying their process, so using electricity more and more inside their process. So I think that's why it's really the good momentum, because 2030, it's very far, but when you need to go from 20% to 50% CO2 reduction, you need to start now. And I think that's why we see more and more industrial people engage on real projects.
Of course, when we hear, and again from Nel, the first person who mentioned fossil fuel parity 2 years ago was Björn Simonsen from Nel. It's kind of a jaw-dropping concept. That is, at some point, hydrogen as an energy carrier for the end user will be competitive with fossil fuels. So that's an interesting, very, very expansive approach. It's a huge goal. But there's other ways of looking at this, and this breaks it down to where you are from sometimes. I had the French Association for Hydrogen and Fuel Cells on the stage. They produce their hydrogen with carbon-free sources of energy, namely nuclear. There's another issue in Germany. What is the issue? We have not only a huge quantity of renewable energies coming from the north in the form of wind turbines, we also have, does anyone think about this, energy dependency. several countries on this earth would not put up with the quantity of energy dependency from foreign sources that Germany has. That is, the country can be shut down within the space of 4 to 6 weeks if there is no ready source of natural gas available. And one of the ways around that issue, of course, is generating large quantities of hydrogen. What I'm trying to suggest is not simply competing with natural gas resources is important. That would be lovely. But energy dependency. And the question to all of you on the stage is, where does this play a role? Does it play a role in the discussion in France about what role hydrogen will play in the overall energy economy? Does it play a role in countries that have so much electrical energy that we all envy them? You can tank your electrical car for free. Does it play a role in Denmark? So, yeah, if you want to start.
So that's a very long question that we can all make a PhD about replying back to. We see a lot of movement in different markets, not just in Europe, but also US and Asia, where the local politicians are concerned about how to decarbonize, but can also see that the dropping price in the renewables will have the necessary effect and make the electricity available. An example, I'm from Denmark. There we have almost 50% of our electricity coming from wind power. Meaning that when the wind is blowing, we are more than 100%. When the wind is not blowing, we are importing. So when the wind is blowing in Denmark, we have our electricity prices off the grid, competing with any other electricity in Europe because it's so extremely cheap. And that creates the opportunity that you talked about.
So interesting to hear it this way round, because very often when I stay on, or when we present on stage, I think people say there is not enough electricity in Europe to produce all the hydrogen you need in all those industries. So I think between us, probably many people think there will be enough renewable electricity in Europe to become independent of imports. I think for the first 20, 30, 40 years, that's going to be absolutely right. It makes sense also to look into other regions for the long term, because if we actually mean what has been said in Paris, that we will massively decarbonize our entire energy life, then we will need completely different quantities of renewable energy than what we can provide with electricity directly. And therefore, for the beginning, I completely agree there is enough cheap electricity so that we can reduce our dependency on external countries. In the long term, I think hydrogen will also become an import good, and we'll find safe places where this can be produced.
Oh, thank you. I just wanted to actually share an insight maybe on Asia, since we have some case projects in Thailand where there's abundant renewable energy available, and you can kind of see a slow adoption and raise of awareness actually in the potential of hydrogen. Exhibitions are being created and the discussion is really kickstarting, and there's a huge opportunity in allowing these emerging markets to leapfrog into the better solution, and I think that's the role that we can all play today.
Yeah, as you mentioned, it's maybe not, we see it like you said, it's not a real competition between gas and hydrogen. So today we want to produce a hydrogen from renewables, and we want to do it in the future as well. But the gas net, for example, you know, there are a lot of studies in Germany or in Europe. So if you look forward in 20, 30, 40 years, there will be for 100 or 80%, we have the electric grid and we have the gas grid. So, and then we have the transition from an energy grid, from the electricity grid to the gas grid. So the gas grid will have an important role in future, especially in Germany or in other countries like Netherlands. So even to transport the hydrogen as a pure hydrogen in a pure hydrogen grid, or to have it in methane, so we have green gas transporting. And until that, we have parallel, we have the world of the pure using of hydrogen for mobility or other parts. So we see it's important to have this both grids, gas grid and electricity. And there will be the world for hydrogen as an energy carrier to use the gas grid.
Yes, I share the opinion of my colleagues and I see more a complementarity for three reasons. As we explained, the first is that hydrogen will help the integration of renewable. We all know that. The second is we are moving more and more from CO2 as CO2 storage to CO2 capture and utilization. So it means now that nobody wants to have CO2 inside the ground. There is too many risks. But you can use CO2 as a feedstock for DME, biodiesel, methanol, and then you create a complementarity with hydrogen to create these chemical compounds with the gas grid and with the methane. And the third complementarity is, of course, economics. Today, we know that oil and gas, it's a cartel of maybe 10 or 20 players, and with hydrogen, you will have thousands of players creating value on microgrid. So it's a good way to create value, riches, and share it on the different regions. So I see a lot of complementarity with the gas grid.
There, of course, is not a conflict between the electrical energy grid and the gas grid. In fact, the business models we heard about last year were grid stabilization. It was mentioned, I think, twice this time around. What are they talking about? Because the grid now is absorbing the lion's share of electrical energy produced by renewables, but it cannot absorb the full quantity. We are turning wind turbines off. The better solution would be to find a way to store that energy. One of the ways of doing that, of course, is creating hydrogen, and then when that's necessary, converting it back into electricity. ITM will be talking tomorrow about this. I just want to remind everyone there was this running debate last year. When you produce hydrogen in such large quantities, you could dump it into the gas grid. Or can you? How many percent? 10%, 25%, that was a debate. But when you look at the gas grid, you're talking about a massive amount of energy by comparison with the electrical grid. It's always worth reminding people that the electrical grid, well, the standard consumer has his heating unit for water and heating the apartment, and then he has his electrical appliances. So 85% is actually natural gas, and about 15% is what people consume in the form of electricity. So that is a massive grid by comparison. And if we transition from servicing nothing but the electrical grid to look at the whole energy pie, it's a whole different dimension. I didn't want to get off on this tangent right there, but I think it's interesting because we haven't heard that side of the debate. We have heard, though, about the automotive industry, which is another huge energy application here. People say automotive. A good question to ask is, where's the infrastructure? Some people are working on local production for local consumption of mobile applications. Instead of waiting for a large natural hydrogen grid, producing it close to a bus station, do any of you have thoughts on whether that's the effective way to go? Is there something like a tank, a gas station element that you can drop into a gas station with a solar cell on the top and it fuels the car? What is the best way to treat the fueling issue?
We've looked a little into that. And you quickly come to the conclusion that if you are to have for just a few hundred kilos of hydrogen produced every day, you need 1 megawatt of solar, and then you need to put the buses somewhere else because the depot is full of solar, and you probably don't have enough. And what happens when it's winter time? The buses will only drive half the distance. So in reality, that typically doesn't work when you look at the business cases. There we see to produce the renewables where you have the space and the land available, use the transmission grids and then connect your electrolyzers to the transmission grids. And basically, you don't necessarily need to operate the electrolyzer. You have the renewable input, but when it's needed in the grid. That could also be when another consumer is not using electricity, and thereby there's a surplus in the grid. So it doesn't have to be next to each other. It can be, and there are places where we can do with the on-site electrolyzers. We have our PEM technology we'll talk about tomorrow, where that's definitely doable, and it's with quite a compact footprint. But business case-wise, in mainland Europe, centralized and then distribution.
I should mention, if you do have a question for these gentlemen, just raise your hand. We're going to be here for a few more minutes. So Don't be shy, just raise your hand. I think twice we heard in this conversation remote applications that are automated, that is, they look after themselves. These are interesting because if you have a small remote application, you might not have an engineer on site who can tweak the dials and so on. It would be optimal if the engineers located in some other place could look after several of these devices. How complicated is that? How reliable is it? Is it up and tested? Do you have good experience with remote applications that are automated?
You can say that the systems that we made is made for it. So you can program a profile if you want how to operate it. So you can then take away, and it works together also with the other components. Like if you have a small refueling station that you produce when you need to fill the tank, or you don't produce, it's automated. There's no requirements, but you can of course also do the programming. So you do actually green hydrogen on site. When you need it, when the electricity prices are low, so you can put all these things into the software to make a load profile how you want to work it, and then it's a good way, as we see many of the operators that will do green hydrogen in the future are not the traditional gas producers. There will be, we see many that have renewable energy in wind turbines or solar farms that are getting off grid or off tariff. The guaranteed feed-in tariff is falling away. That means that you have to convert it into something else. And these clients are very interested in making green hydrogen and sell the green hydrogen to make more money than if they sell the electricity. And here again, it has to be automated because it's not specialists in hydrogen, but they are just business people that want to find a new way to convert the energy to a continuous money machine. So that's why it's very important that it's automated and it can be remotely managed and have a central center to manage and look at everything, so we can intervene in time if there's any problems.
Thank you. So we also have the remote monitoring capabilities. As mentioned before, we were created in November 2017, so we've been testing it out since then, and it's pretty amazing, honestly. It's a very granular analysis of the hydrogen production, the PV production. The network of sensor really collects all of the data in real time, which allows you a perfect understanding of what's actually going on behind this whole system. You get to understand it even though you might not be an expert. As you mentioned, it might not be a hydrogen PhD knowledgeable person, so it's a good way to not only understand how much hydrogen you have available, but what you can actually do with it. And that's sometimes the translation that's a bit complicated to understand and to monetize.
Your question was, so can we run in an automatic way the units, for example? So I will give an example for large industrial units. Yes, for sure, you will use some supervision tool, Siemens-based or Schneider, whatever, and these kind of units can be driven by only one operator to make only some checks, and he receives alarms. On the other way, you will need, because these are industrial systems with capture, sensor, pumps, stuff like that, so you will need to check it and operate with maintenance. And the good news is that these are added value jobs, because for maintenance you need automation skills and people, electrical, mechanical. So the jobs around are also interesting in terms of value, and the job is usually attracting a lot of young people. Supervision, installation, automation, the same as we have for wind park, more or less.
Okay. Back to a debate we were having a year ago. What's driving the increasing demand for hydrogen? I had Asahi Kasei on the stage today, a Japanese company. They also do alkali electrolysis. They've got a big unit here for the first time. Japan, of course, has launched a large series of hydrogen cars. The Toyota company had a contract to work together with Tesla to develop batteries. They backed out of that. That is, they do not they're not banking on the electric car as much as they are on the hydrogen car. And then to go back to statements made last year, there's just not enough copper to provide charging facilities for all the electrical vehicles if they were all electric. Interesting in this conversation was the Japanese take on hydrogen. They do not have renewables. So I asked him, okay, you've got these hydrogen cars. Where are you going to get the hydrogen for all these cars that are being produced in Japan right now? And he said, wait for it, we'll import it. Is hydrogen an exportable commodity? Any takers?
So it comes back a bit to the point that we discussed before. I think a key driver of the economics of hydrogen production is the electricity costs. And if you look around on the planet, Europe is certainly not the place with the cheapest electricity costs. So it is actually quite obvious to go to places where it can be cheaper. It's probably not the initial scenario, in my opinion, because it will take a while to build up the logistic chains, and I think then also the group of electrolyzer people might not actually be the problem, but the whole transportation, compression, liquefaction, whatever comes with it is also going to deserve some more closer look on it. But for me, it makes perfect sense in a world that is run by renewables only, that a huge amount of the energy will be imported, and hydrogen is certainly going to be part of the answer in that scenario.
Just an add-on comment for that. We have been participating in quite a few studies on producing hydrogen on one side of and distributing it to another side. One of these were in Norway, where some of the fjords up far Norway, there's a lot of hydropower available. The same goes for Iceland with the geothermal power. I think Iceland made a project 15 years ago or something about exporting hydrogen, liquefy it, and distribute it. So I just came out of Korea. I was there last week, and I've been to Japan many times. They import, it's all natural gas. So it's CNG, but mainly LNG. So you can almost use the LNG carriers for hydrogen as well. It's not that great difference depending on who you ask. So producing hydrogen scale from renewable places like Middle East, like Norway, like Iceland, like Australia would be obvious choices, and I think that's what they will bet on for Japan, for Korea. China, they will have their own sources and have them already.
And so Japan is a specific case with the island, but closer to us in Europe, you have already some hydrogen grid from Rotterdam to the Ruhr to Germany. This grid could be extended, and then it's a good way to make import-export to balance the production of energy and the distribution of hydrogen to the place of consumption. The question will be the cost of extending the infrastructure of hydrogen, but I know that different countries, Holland, Belgium, and Germany, and north of France are looking and making an extension of this hydrogen grid. So it could be a good way to make it as a commodity and transportation.
So I totally share the arguments. So I guess the main focus for me is to have a centralized production near to the customer. You have, for example, in Germany, so to have a few megawatt and to have the hydrogen for the mobility appliance or for the industry. But in the end, we will have both. I guess centralized bigger ones, very small one, and then huge hubs, production hubs, even if it's in Europe, Northern Europe, Netherlands, or I don't know. So, and then to export or to import, as you see, the hydrogen. Yeah.
The temptation is to go on and on because there's so many finite issues here. I realize it's hot in the lights, and people are the beer's already being served in the lounge, so we're all getting thirsty up here. It's very true. There's so many other issues to talk about. Even we talk about the grid. Electrical energy going from the north to the south of Germany, you may lose 30% with all the modifications. Transporting gases is notoriously easy, just a little bit of pressure and they travel along their way. So these all play into how large a market is existing right now, how effective and efficient that is. To wind up this whole presentation, so rather than forcing certain points here, such as the debate between PEMs and solid oxide and alkali, where we always get stuck on this, which is a faster response and how essential is. I think it would be more interesting to hear from each of you briefly what's up for next year. We hope you all return in 2019. What do you think your achievements will be within that year's time, or what will have changed in terms of your markets? I don't know whether we want to begin on this end there. Go ahead.
I'm always ambitious, so I expect us to have signed large multi-megawatt projects, not just in Europe but across the globe, for units that will basically make fossil parity. Hereby recorded.
Great.
So I think more globally speaking, next year we will see what will probably become one of the biggest trends in renewable energy development. So hydrogen markets, real markets with real commercial is starting to be visible at a much larger scale, probably already next year in April, with changes in legislation, for example. And for my company, megawatt level has been achieved, probably reaching multi-megawatts next year, and we'll facing PEM and alkaline, and we'll have fun again next year.
For our perspective, what we will do is try to get more and more partners into the hydrogen game. We will focus a lot on renewable energy suppliers in order to have new players producing and delivering green hydrogen into the ecosystem. That's much more on sustainable business models that we are working on, without any subsidies or anything. We want to focus on doing real business with real people that can have a business up and running. So we will not go up in a megawatt scale. That's not our ambitions, even though we can. But we want to find a number of good partners and work with these partners to make them have a good business. So like we normally say, we want to make our partners millionaires, because then we will also be doing quite well.
On our side, it's really pushing the R&D to make our AEM electrolyzer better, stronger, faster. Just really the ultimate electrolyzer for small-scale application, and deploying the energy monitoring system to really test it out and prove how efficient it is, how granular it is, and also to encourage many more collaborations. I think, as we've all stated, I think that's key in terms of facilitating the energy transition with hydrogen.
As I see for the next year or next years, I see a lot of more projects coming on in the mobility part, but mainly for the 350 bar for buses or trains. So hopefully we can join there with our partners, the fueling infrastructure. And on the other hand, there will be a lot of more projects coming on, building up in Europe for bigger, large-scale electrolyzer processes, systems for industry.
Well, let's have fun and let's be short. Gigawatt.
Yes.
Why gigawatt? Because today there is a Gas World Conference in Amsterdam, so it was difficult to be everywhere. And I know that more and more countries, Holland has already a plan to have gigawatt plant for electrolysis by 2030. There are several projects in France of gigawatt plants and units, and in Germany. So what I would really hope is that each country in Europe, and I know there are a lot of projects in Asia, of course in China, will have their gigawatt plan, and then it means we have gigawatt solutions to do it, and a lot of players will take part of it, so that makes a lot of fun.
So it's a booming industry. There has to be a reason why the space at this fair is now being taken over by the electrolyzer branch, and we're happy to have you here, of course. I'd like to remind everyone that the second half of this presentation is tomorrow. We have so many people involved in this industry in various ways that we split the group into two. I want to thank my guests today. It's been, and for your patience under all of this heat. You've earned your beer. I've been talking to Bertrand Amelot, who's Executive Vice President of Sales and Marketing at McPhy. Carsten Krause, who is Managing Director at Areva. Henrik Steen Pedersen, Executive Vice President at Sales and Partner Management at GreenHydrogen. Nils Aldag, who's CCO at Sunfire. Jakob Krogsgaard, who's Senior Vice President of Nel Hydrogen. And Vaitea Cowan, who's marketing and the new player with a strong product from Enapter. Thank you all for your patience and your time, and hope to see you back here next year.
Yeah, so.
And with that, our presentation is finished for today. We wish you all a good evening, and hope to see you back here tomorrow at 3 o'clock for the second half of the hydrogen program.